Right, how we doing, guys? So here's the deal for week 6. Um, we're gonna take our old two-column proofs and apply them to quadrilaterals, parallelograms, and stuff. Woo! All right, so follow along on this. I'm trying to make it as streamlined as I can and help you out as much as possible. So on your Schoology page, this is for period 2, but it'll look the same for everyone. Under your lessons and assignments, right, you'll see week 6. Now, you can't see it right now because it's unpublished, but it'll be published tomorrow. So you're going to go in here. Obviously, the read first, which I always want you to read first, hence the title. The instructional videos, which, believe it or not, I do not want you to skip. This resources section is going to be important, all right? So in the resources section, you're going to have 3 documents. Don't ask me why this one gave me a little snapshot of it, but the proof reasons for quadrilaterals. This is a big one for this. I'd print this out if you can, or at least have it available to you to toggle back and forth as you try to do the assignments. Has a list of all the quadrilateral proof reasons, so you don't have to reinvent the wheel here. There's the summary sheet for the properties again, and that same that chart that I've used for the last 2 weeks now. So I included it all here, so it's right there. Now, getting back to this, so inside the week 6, those were the first 3. Now you'll notice there's 2 assignments. So this is going to be like that first week, week 3, where you have both an assignment to submit as well as an assignment to do on Castle. So your assignment will be within here. All right, again, use those resources. So with that in mind, let me go to the first proof that I want you to be able to do. This is called, this is just, I don't know why I said this is called, this is an example of a rectangle two-column proof. So in this case, they're telling you, big given, that it's a rectangle. That means all those parallelogram properties apply, all right, as well as all the rectangle properties apply. These are not diagonals, so you can't tell me the diagonals are congruent because it doesn't go from opposite corner to opposite corner. All right, but it is telling me that BE, this little piece, and this little piece here, CF, are congruent, and that the big guy is a rectangle. And they want you to prove DE and AF. So look at where DE goes and AF. Now, you're still going to use, in most cases, you're still going to use triangles in this. All right, so can you see the triangles? Well, there's a bunch of triangles. There's probably like 4 triangles in here. But this guy here and this guy here certainly aren't congruent. So you want to see the bigger guys, the overlapping triangles. And if you can get them to be congruent, then you're at a nice, easy CPCTC on those 2 sides. So you want to target those 2 to be congruent. All right, so with that in mind, you tap into what you know about rectangles. All right, here we go. So I went over with a highlighter just to make it a little bit more visible for you. Now, let's start looking at what we got. I have the rectangle piece, which I know means that the opposite sides of a rectangle are congruent. So just like that, my orange and pink triangles here have a congruent pair of sides. Now, one of the other things I have is that I know that in a rectangle, see angle C and angle B? Those are 2 of the angles of a rectangle. Now, rectangles are equiangular. So you know that all the angles are congruent. You could have instead gone the route and said angle B and angle C are right angles because all the angles of a rectangle are right angles and then all right angles are congruent. You could have done that, but it's just easier to streamline it and go right to, boom, equiangular. All right, and then that other given, that little BE and CF, those are not full sides. You have to make them into full sides. And we make sides bigger with addition. All right, so with that picture there, I hit up AB and CD as being congruent because the opposite sides of a rectangle are congruent. I hit angle B and angle C as being congruent. Rectangles are equiangular, or all the angles of a rectangle are congruent, however you want to say it. Now, I know that if I'm going to use this overlap, all right, to make these segments longer, I got to hit the reflexive up first. So I got FE congruent to FE, reflexive. And then I can write the addition postulate like I did a million times in class. All right, CF plus FE is congruent to FE plus EB, or the actual segments I want with addition postulate as my reason. Now, that gives me a side, an angle, and a side. Side, angle, side. So the triangles are congruent by side, angle, side, and that gives me those pieces, the proof statement, DE and AF congruent by CPCTC. So I hope you can get an idea of what we're kind of talking about by applying the quadrilateral properties, the parallelogram properties, the rectangle, the rhombus, the whatever. Applying those properties, right, to now being reasons to prove whatever it is you're trying to prove. All right, I hope that helped. And next one's a little bit more involved, and there's two different ways. I want you to follow both ways. So stay with me on that, all right?